Chapter 4, Section 6.4, Part 3 video. On these next couple examples, we will be working on solving quadratics. So the Rightwell Incorporation makes a fountain pens. Its cost is 0.0075x squared plus x plus 2100, which is a quadratic. Dollars to manufacture X pens, and the company will receive R equals 13x dollars in revenue from the sale of pens. So we have a cost equation, which is a quadratic, and then we have a revenue equation, which is linear. And it says find the break-even points by solving the system of equation. Well, first thing we need to do is put the first one in calculator. 0.075 plus x plus 2100. All right, and then revenue is 13x. So we have cost, which is 0.0075, and then revenue. Now, what in order to find break-even points, it's basically where these two intersect. So if I hit graph, well, first thing I need to do is zoom 6, right? And then zoom 0 for zoom fit. Yeah, okay. So let me get my window limits to like that. Let's see, negative 100. Let's just go out to 1,000. We'll step it by 50. And now let's just kind of see. Alright, so we get a little bit of blip on our screen with that blue up there for quadratic. So zoom 0. There we go. So we got one break-even point here. And we need to find the other one, which is above 1,000. So let's go 2,000. Graph. Zoom 0 to see all of it. There we go. So we've got these 2 points right here that are break-even points. Now, in order to find those, we have to do second trace, and we're going to hit number 5, which is intersect. So we'll move over here to this first intersection. And that's 226. So let's do, all right, so 200 and 2600. Okay. Now let's go find the other. Second trace, number 5, intersect. We're going to move over there to this one's other intersection. That's why they said solve it like a system of equation, because you're looking for the points at which they intersect. All right, 1,400 and 18,200. They can't see it, right? Yeah. All right. So find the break-even points. So here's where your cost and revenue break even at these 2 points. So they would go in there. Okay. And they'd have a comma between them. Now, they say points, plural, meaning 2 of them. So we need to put both of them in there, right? Both sets of order pairs. Now let's look at this. We need to look at use the fact that profit equals revenue minus cost to find the value of X, which the profit is maximum. Well, we basically, revenue is 13x, then minus cost is 0.0075x squared plus x plus 2100. Well, if you distribute that negative 1 in there, that gives you 13x minus 0.0075x squared minus x plus, no, not plus, sorry, minus 2100, and then we get profit equals, here's combining like terms, right? Here's like term, there's like term. Profit equals negative 0.0075x squared plus 12x, no wait, sorry, yeah, plus 12x minus, if I get the right one, minus 2100. So this is what we're going to put in our calculators now. And here we go. All right, so if we graph that, we see that we have a curve, and if we go, let's change our y limits a little bit. Let's go, maybe that's 34,000. Let's go 15,000. There we go. That's a little, we could probably bring it a little bit lower. There we go, graph. All right, so let's go see what it says. Find the value of x, which of profit is maximum. Okay. So all we want to find is the x value of the vertex, that maximum point up there. So second trace, 4. And I want to come over here on this side. Hit enter, and then go on the other side. And then hit enter. That creates left and right bound. And then hit enter in the, again, to give you that point. That's 827. So that's 800. Now, which one do they want? They want a value of x, so that would be the input. Okay, the profit that you would make, if they said what is the profit, that would be 2,700. But you need 800 pins in order to do that. Okay. Now, last one on this one, this video. Delbert launches a Tory water rocket from ground level. Its distance above the ground t seconds after its launch is given by this equation. When will the rocket reach its highest, and what will that height be? Okay, here we go. We're going to graph it. So clear this out. It's a quadratic. We just need to find how far it went up, right? Okay, so 128t, which is x minus 16t squared. Okay, just hit graph. Let's do zoom 6. All right, so we see both sides, and then we're going to do zoom fit, and it's going to give us that. Okay, so we're going to clean our window limits up. We're going to bring the top down and the bottom up. So that's the y's, right? And 350, I'm just choosing some number above where the limit was so that it pushes the screen down. We'll step it by 50. So if I hit graph again, there we go. All right, so we need that maximum point up there. So second trace 4, and other side. Enter, and then hit enter again. At 4 seconds, it took 4 seconds for it to get 256 feet up. Okay, so 4 comma 256. This is time, and this is height, right? So let's go answer the question. The greatest height attained after 4 seconds was a height that was 256 feet. Okay, so that's what we verified on that calculator. The only other thing that they could ask you from this type of question is, when will it hit the ground? And that would be a second trace, number 2, do a 0, right? Because that would be the 0 or solution or x-intercept, right? You note that it started at 0 on the height, as far as the height above the ground is 0, so it started on the ground. So that's why it went through 0, 0, the origin. And if it took 4 seconds to get up, now this only works if it goes through 0, 0. Okay, you cannot do this little trick, or understand, I shouldn't say trick, it's more of an understanding, because quadrats have lines of symmetry, which means you can fold it about the axis of symmetry. If it took 4 seconds for it to go up, then it takes 4 seconds for it to go down. Now, this is only because it went through the origin, which means it started on the ground. If it started somewhere other than the ground, like 50 feet up or 20 feet up, that wouldn't be true. So that would be 8 seconds, right? So that's a little thing that can help you time-wise. Yeah, okay. Let's do this one. Basically, the owner of a small fruit orchard decided to produce gift baskets, a sideline job. Basically, the cost per basket for producing X baskets is given, right? They want the minimum cost, and that obtained when X baskets are produced. So we know it's opening up because our A is positive, right? So we'll just go to our calculator and get this one pretty easily. 0, 0, 1, x squared minus 2x plus 120. All right, so I'm just going to hit graph. All right, I don't know anything about what's going on, so I'm just going to hit zoom 6. And then we'll hit zoom 0, because somewhere on this thing it's going to be showing. Okay, so we need to open our limits more than 10. So let's go negative 100, and then 100, and step it by 10, and just hit graph. Let's see what happens. All right, let me make sure I got a quadratic. Yep. Okay, good. Let's open them up more. Well, let's do this. Graph here. Zoom fit. There we go. We're getting a little bit more of the curve. So need to open up more to the right. So that would be, I'm going to go 300. So we hit graph. Okay, there we go. Now let's give a little bit of there. There we go. We'll give a little bit of room down here. We're going to find that minimum value. So second trace 3. Moving those limits just takes practice, and all I'm doing is just making things look pretty on the screen. Normally zoom 6 and then zoom 0 to fit it works good. You can always adjust your X's and then graph it and hit zoom fit to adjust your Y's, and then go in and tweak from there. But it just takes a little bit of you spending some time getting comfortable with that. But once you got it, you're good. So we've got 100 comma 20. All right, so the cost produce X baskets. So this is baskets, right? That's the number of baskets, right? And this is cost. All right, so find the minimum algebra. We're not going to worry about it algebraically. We're doing it on a calculator. The minimum cost per basket obtained is when 100 baskets is produced, and that cost is $20. And we've already verified that on our calculator because that's what we've done. So this concludes Chapter 4, Section 6.4, Part 3's video.